This is USNCO Locals 2024, question number 5. 1.22 grams of benzoic acid is dissolved in water to a total volume of 150 milliliters. A 10 milliliter sample of the solution is then withdrawn and diluted to 500 milliliters. What is the concentration of benzoic acid in the final solution? Okay, so we're given the grams and molar mass, and we have the total volume at the start, the initial volume, and the final volume. So we're trying to find the concentration. That means that we're probably going to use an equation like M1V1 is equal to M2V2. Alright, let me move this up. Okay. So in this equation, we're trying to find M2, the final concentration of benzoic acid. But we don't have M1, right? So to solve for that, we can just do this. Moles over liters. Give it to grams and we'll take it in milliliters, so we can just convert that. So 1.22 grams of benzoic acid. The molar mass is 122.12. 1 mole, 122 grams. So 1.22 divided by 122 is equal to 0.00999 to 0.01. So this is the initial of benzoic acid we have. So 0.01 over liters, which is, we're going to use the total volume, right? 150 and 0.001 to convert to liters. That's 0.15. Then you're going to result in an initial concentration of 0.067. Okay. So now you can just like plug and chug, right? So you have 0.067. I think it's easier if I do it down here. Times V1, which is 10 milliliters, is equal to M2 times V2, which is 500 milliliters. Okay. So the final concentration 0.00134. So M2 is equal to 0.00134, which is matching this one. A. Okay, so question number 6. A 0.75 mole aqueous solution of which substance has the lowest freezing point? So we're given a molality, right? Molality. 0.75 molality. You have to find the lowest freezing point. That's laying the freezing point depression equation, which is change in the freezing point depression is equal to, if I remember correctly, I times KT times the molality. Okay, so this is, of course, the molality. This is the, right, some constant, right? It's a constant. Oh, what was it called? Cryogenic constant or something like that. And then I is the Van 't Hoff factor. Okay, so here there's two constants, right? This is always going to be constant. We can just forget about it. And then molality is also constant, 0.75 mole in each substance, right? That's also constant. We're going to be relating the change in the pressure point with the Van 't Hoff factor. So we're looking for the lowest freezing point, right? So the greater the freezing point depression, the greater the Van 't Hoff factor. We're looking for a greater Van 't Hoff factor. And before you're looking for that, you need to understand what that is, right? I. So what I is really relating is the ions that are being dissociated. And looking at these, you can see that these are all acids, right? Specifically, HF is a weak acid. It's a weak acid. This is a weak acid. But HI is a strong acid, right? And what the definition of a weak acid means that it partially dissociates, right? It partially dissociates. So when these ions dissociate, it's going to have a Van 't Hoff factor, right? Strong acids, they dissociate at a very high rate, right? They create dissociation. So they almost fully dissociate. They practically do. So when we're looking at this, we're looking for which has the greatest Van 't Hoff factor. So if you're taking just HF, HI, let's just take that. HI dissociates to H plus and I minus. Van 't Hoff factor is going to be equal to a nice 2 because it's going to practically dissociate into 2 ions. And what makes that different from the others is that weak acids don't dissociate completely, right? Or actually, they barely dissociate. HF is probably going to have a dissociation of less than 2, right? Or less than 2. So HI is going to be having the lowest freezing point with the greatest Van 't Hoff factor because it's a strong acid.